यहाँ पर हम बेसिक कंसेप्ट्स ले रहे हैं कोलिजन से रिलेटेड, जिसमें पहला है when two bodies physically collide against each other or when path of one body is changed just the influence of the other, or when the path of one body is changed just by the influence of the other body, either of the case, then the collision is said to take place. Only then we'll mention the collision is there. A collision is of two types, elastic and inelastic. A collision is said to be elastic if the kinetic energy is conserved. Kinetic energy before and after collision is an important one. It is an important criteria that will tell whether the collision is elastic or not. So if the kinetic energy is not conserved, then the collision is said to be inelastic. If the sorry, if the two bodies stick together after collision, then collision is said to be perfectly inelastic collision. It means in this collision there is not the conservation of the kinetic energy. Momentum and total energy are conserved in all type of collision. So when we are talking about before and after collision, if the momentum is taken or total energy is taken, either type of collision it is there, they are going to remain conserved. If the colliding bodies move along the same straight line path before and after the collision, then the collision is said to be in one dimension, or it can be called as head-on collision. In one dimension elastic collision, the magnitude of the relative velocity remains unchanged, but the direction of relative velocity is changed. The next point is about if the two masses of m1 and m2 move with velocities v1i is the initial velocity of mass 1 and v2i is the initial velocity of mass 2. Suppose these bodies after one dimension elastic collision, then v1f and v2f, these are the final velocities of masses m1 and m2 after the collision, and these velocities v1f is equal to m1 minus m2 upon m1 plus m2 into v1i plus twice of m2 upon m1 plus m2 v2i and v2f. Here these velocities will interchange and rest the things remain same. m2 minus m1, interchange of mass is also there in the subtraction, upon m1 plus m2, this is v2i plus 2 twice of m1, in place of m2 it is m1 plus m2 v1i. Next is when the two bodies of equal masses, the masses are equal and they are suffering one dimensional elastic collision, they interchange their velocities. The velocities will get interchanged when these two bodies will interact with one another. The masses are equal. When a massive body suffers one-dimensional elastic collision with a stationary light body, here the two bodies are there, massive is in motion and the light body is stationary. Then after collision, there is no change in the velocity of massive body, it remains as such. But the light body acquires velocity which is nearly double the initial velocity of massive body. For example, if massive body is moving with velocity u initially, after collision with a light body, there is no change in the velocity of that massive body, but the light body will be moving with nearly equal to twice of initial velocity after the collision with the massive body. When a light body suffers one-dimension elastic collision with a stationary massive body, here the case has been changed. In this case, the massive body is at rest and light body is moving. And after collision with the stationary massive body, the velocity of the light body is got reversed. The direction of the body get reversed. But the massive body practically remains at rest. There is no movement in the massive body practically. A collision is said to be oblique or two-dimension collision if the colliding bodies do not move along the same straight line path before and after the collision. This is the famous Einstein's mass energy equivalence, E equal to mc square. According to Einstein, if any body it is moving with the velocity of light, then that mass converts into energy according to this relation, where m is the mass of the body and c is the velocity of the light. Let us see the first question on the topic collision. Two bodies of A and B having same mass undergo completely inelastic one-dimensional collision. The body A moves with velocity v1 while body B is at rest before collision. The velocity of the system after collision is v2. The ratio is these four options have been given, and this question has come in NEET 2024. It is on page number 84 of new NCRT. So let us draw the conditions that have been given before collision and after collision. Before collision, the body A is moving with velocity v1 and the body B, it is at rest. It is not moving. This is before collision, at rest. And after collision, the velocity of the system means A and B have become a system and they are moving with velocity v2. This is after collision. One more thing is being given. A and B are having the same mass. Let A is having the mass m, then B is also having the mass m. And after collision, it is a system with a mass 2m. Now, we'll apply the concept according to that. Whatever is the collision, whether it is inelastic or elastic collision, the momentum remains conserved. Momentum is going to remain same. First, we'll apply about the momentum. Since momentum remains conserved, therefore momentum before collision is equal to momentum after collision. Now momentum before collision. The body A is having mass m moving with velocity v1. This body is having mass m but it is at rest, so velocity is 0. This has become a system of twice m moving with velocity v2. So m v1 is equal to twice of m v2, and v1 upon v2 is equal to 2 by 1, or the ratio of velocities come out 2 is to 1. Now if we look at the options, our answer goes with option number B, and the answer for the first part is B. Now let us see the question number 2. Body A of mass 4m moving with speed u collides with another body B of mass 2m at rest. The collision is head-on and elastic in nature. After the collision, the fraction of energy lost by the colliding body A is, and these are the options given. This question has come in the NEET National 2019. To solve this question, see whatever the things have been given. Body A, the mass is 4m and speed is u. The body B, its mass is 2m and initially at rest. Now, there is a collision, head-on collision and elastic in nature. After collision, see after collision, let body A moves with velocity v1 and B moves with velocity v2. Then we know the concept that whether it is elastic or inelastic collision, the momentum and the kinetic energy remains conserved within the system. Then, according to the law of conservation of momentum, we have 4mu plus 2m. Initially it is at rest, so the velocity here is 0. This is equal to 4m v1 plus 2m v2, and from here we have 4mu is equal to 4m v1 plus 2m v2. Can take out 2 common, and m also. 2u is equal to 2v1 plus v2. So mark it as equation number 1. Now we need to find out the amount of energy lost by colliding body A. So we need to find out how much is the value of v1, because v1 is the velocity after collision. If we know the velocity after collision of A, we can find out this value. To find it out, let us take the law of conservation of kinetic energy, that is half 4mu square plus half 2m 0, because there is no velocity there, half 4m v1 square plus half 2m v2 square. So from here 2m, this is taken out common, so we are left with 2u square is equal to 2v1 square plus v2 square. This is your equation number 2. On solving equation 1 and equation 2, we get v1 is equal to 1 by 3 of u. So this is how we have calculated the velocity of the body A. Now to find out this velocity, we can use the direct formula also, if you remember. Let us see that. There is an alternate method to find out the velocity of body A. If you remember the formula, v1 can be given by m1 minus m2 over m1 plus m2 u1 plus 2 m1 m2 over m1 plus m2 u2. It is 4m minus 2m over 4m plus 2m, and the value of u1 is u. u2 is 0, so we are remaining with this. We will have 2m by 6m u, so it is u by 3. Now we need to find out the fraction change of the kinetic energy. So change in kinetic energy. First we'll find out the change in kinetic energy, that is half m u square minus half m, this time it remained u by 3 whole square, for body A. So This value comes out 16 by 9 mu square. Now fractional change in kinetic energy. This is given by change in kinetic energy to the original kinetic energy. So this change is 16 by 9 and the original kinetic energy is half 4m u square. That cancels out to m cancels with m, u square cancels with u square. So this 2 goes with 8. So the value comes out 8 by 9. And here the option number A goes with the result. So the answer for the second is option A. The lost or the change fractioned energy of body A is 8 by 9. A particle of mass 5m is at rest, suddenly breaks its own into 3 fragments. 2 fragments are of mass m, move along mutually perpendicular direction with speed each v. The energy released during the process is, and the 4 options have been given. This question has come in NEET Odisha 2019 and this is on the page number 85 of new NCERT. So here we are having the mass 5m. This mass was at rest initially, and when it broke into the 3 fragments, 2 fragments are of mass m and they are moving with each speed v, but they are mutually perpendicular. The energy released during the process. So when out of this 5m, so this 1m, another will be the thrice m. So total of that will become 5, and let the velocity be for that is say v dash. These two are moving with the same velocity v. Now let us write down the equations for it. Before collision, the momentum is 5m into 0. After collision, the momentum is mv I cap plus mv j cap plus 3m v dash. We have taken I cap and j cap as the direction for these two. Let these two are mutually perpendicular and these are the caps giving the direction of that. Now momentum is conserved, therefore 5m0 is equal to mvi cap plus mv j cap plus 3mv dash, or minus 3mv dash is equal to mvi cap plus mv j cap. Mass cancels and v dash is v by 3 I cap minus v by 3 j cap. I've shifted the minus sign that side and m has got cancelled out. Now the magnitude of v dash, the velocity for the third mass, can be found out. minus v by 3 whole square plus minus v by 3 whole square. So the value comes out v square by 9 plus v square by 9. It is the root 2 3 into v. So the value of v dash is equal to under root 2 by 3 into v. We have calculated this v dash is equal to under root 2 by 3 of v. The energy released during the process is given by half mv square plus half mv square plus half 3m into root 2 by 3 v whole square. So this value become half plus half mv square plus 1 by 2 3m 2 by 9 v square. So this is mv square plus mv square by 3. The value comes out 4 by 3 mv square. So this is the total energy released during the process. And if we look at the options, our option number D goes with the result. So the answer for the third is D option, 4 by 3 mv square. This is a question about the coefficient of restitution E for a perfectly elastic collision, and these four options have been given. This question has come in All India PMT 1988, and it is on the page number 84 of new NCERT. See here, first you make it clear what the coefficient of restitution is. It is equal to the relative velocity of separation after collision to the relative velocity of approach before collision. Since for a perfectly elastic collision, for a perfectly elastic collision, we have relative velocity of separation after collision that is always equal to before the collision. This is equal to the relative velocity of approach that is before collision. In short, we say the velocity after collision remains same, that is before the collision. So because of that, these two values are same. So value for E comes out to be 1 for the perfectly elastic collision, and it goes with the option A, and the answer for the fourth is A option.